Hi everyone, and welcome to the presentation and demonstration of how to unleash the value of SAP data in Databricks. My name is Julius from Initials. I'm the product lead for SAP. And to start off with, well, SAP data is ubiquitous in many industries, especially in the enterprise context. And therefore, it's vital for many data science and machine learning use cases to tap into that value and use that data. And the problem is that SAP data oftentimes is not so easy to get access to. And there's a whole process of how to gain access to that SAP data, which I would like to show you over here. So usually you would define a use case on the left side, and it takes a significant time before the data is available on the right-hand side. So you need to go through many steps. For example, you need to involve the SAP basis team, you need to talk to them, then you need to find some integration experts, you need to find them, you need to onboard them, and finally you need to develop and maintain that integration platform. You need to set up a VM, install an ETL tool, and then you need to develop those copy pipelines, for example, to get the data available. And all of that takes time. Involving the SAP basis team takes 1 or 2 weeks. And finding and involving the integration experts takes a couple of weeks. And of course, developing and maintaining the platform takes a couple of weeks as well. And then oftentimes data is missing, and then you have to go back and repeat those steps. And before you can actually start that use case, several weeks go by. And in reality, we know, of course, that those planned 1 or 2 weeks often in reality doubles and takes 1 or 2 weeks longer, and for the other steps as well. So it takes several months, sometimes half a year, until you can actually start testing if that use case, if that proof of concept makes any sense to involve and integrate that SAP data. And it just slows down the development significantly. So we at Initials, we've come up with a solution which drastically reduces that time. So we have a very lean architecture, which I will show you in the demonstration just now. We're building on standard SAP interfaces, and everything is within Databricks. So it's an interface from Databricks to access SAP data directly, which I would like to show you now in the demonstration. So let's head over to Databricks. So I'm logged in here. I've got a notebook. It's connected to a repository, as you can see over here. And to start off with, I would like to show you the architectural overview of the solution, which is called direct data extraction. So on the left side here, we've got our SAP system. It's any type of SAP NetWeaver system. So it can either be an ERP system or BW system. And then in the middle here, we've got our Databricks sitting notebook with our solutions and provided functions, with which you can directly access any type of objects within the SAP system. And you can load that into a data frame, and then you can also persist that data frame, of course, in your data lake or lakehouse structure using the Delta format or any other type of format as well. So in this demonstration, I'd like to show you how to connect to the SAP system from Databricks, and also how to do that securely. So how to use the SNC framework to encrypt the data. And then I'll show you how to load data from these different objects into your data frame. First, we'll load some tables into a data frame, and then we'll use the ODP framework to load different objects across as well. We can do that for CDS views, we can do that for HANA objects, and we can also do that for extractors. Extractors usually bundle a number of SAP tables and add some additional business logic sometimes, and many times these are Delta enabled. So they're standard extractors provided by SAP, and some of these are Delta enabled, and I'll show you how to extract that in full, and then how to do that incremental Delta load to load that into your data frame. The CDS views are also often standardly provided by SAP, and some of these are also Delta enabled, for example. And what is not shown, but which is also capable using the ODP framework, is any type of BW objects. but here I will connect to an ERP system. So let's head over to the first step. So number one, before I can connect, I need to, of course, first import some libraries that we've developed from the solution. These are Scala libraries. And then because many people don't want to use Scala, they'd rather use Python, we've also developed a Python wrapper so you can access these Scala libs. So now we can use Python to connect to our SAP system. So now we're going from Databricks. We need network connectivity, of course, but to connect to our SAP system. And to do that, we need to define a few configs, as you would usually do with other tools as well. So you need a host and IP address, which I've securely stored here in an Azure Key Vault. We need a system number, we need a client, we need a user and password, which are also securely stored. And we need to give a config ID over here. And if we do that, we can hand that over to our function and initiate a class, subloader, and then we can call the function .connect. And if we do that, so now we've established the connection. We can also do the same using SNC, so to do that securely. We need a few more parameters to do so. So in addition to the config name and the user and client and system number, we also need an SNC name. For example, this could be my email address, for example. We need the SNC partner name of the system. So it's just a generic SNC partner name that I've set up in the ERP system. And we need a security level, so you can really decide what you want to encrypt. Do you want to encrypt only the username and password? Do you want to ensure integrity? Or do you want to encrypt the entire data that is running across for your integration workloads? And then you pretty much do the same thing. You give the connection details, and then you call a connect, and then you've connected using SNC, and everything is secure. Right, so now we've connected to our SAP system from within Databricks, and now we want to, of course, load some data. And first thing that we can do is we can load some tables into a data frame over here. Now we can define a few parameters again. For example, the maximum number of rows. Decided now 100,000 is enough for this demonstration. We can also load that in different batches. For example, now I'm just loading it in one batch. And you can also define some parallelization reading threads, but we're just going to use one for this case. And we can load different types of tables. As a start, I'll load the table JCS, and then I will display it over here. And you can see now, here's your SAP data. So it just took just a second, and you've got your data in a data frame with the correct typing as well. So a date within the SAP system is a date in your data frame. An nvarchar is a string. A decimal is a decimal, and so forth. So you don't need to worry about casting or converting anything by yourself. You can, for example, we can look at the data frame here, and we can see we've got a double, and we have a string, and we've got a date. So the mapping is done for you. You can also, of course, take a look at any other tables, for example, the business partners. But before we do that, we can also count the data frame that we loaded in. We can see we've loaded now approximately 50,000 rows into Databricks. If we now load the business data, so from KNP1, the table, we can also do that and see from our example data that rapidly shows up within Databricks. Of course, we can also push down some where statements. For example, if we only want the customers from country Germany, we can do that as well. And if we only bother with these three columns, Kundennummer, customer number, the country, and the name, then we can push that down to the SAP application and get only the data that we're really interested in. And now, once you've got that data in your data frame, of course, you can do anything that you would usually do in Databricks. For example, we can now import PySpark, regex replace. For example, if we take a look at the customer number here, we want to replace the zeros and get another column called manipulated customer number or Kundennummer. Then we can do that, of course, as well, and do everything that we want in Databricks. We can combine it with other data that we might have, test something out. Does it make sense? Does it combine? And do everything that we usually do in Databricks. So that's for loading tables. Now we would, of course, also like to load some other objects utilizing the ODP framework. And first off, I'll show you how to load data from a CDS view. It's pretty much the same as for the table. Again, you define a config. This is called ODP config over here. We need the ODP name. For example, here, this is the material group. We can also load material evaluation or item category, for example. But let's load the material group CDS view, which is supplied by the application. And we need to define a ODP mode. So this can either be full or for the incremental load, which I'll show later on, delta. And then we need to define the ODP context. For example, our CDS, because this is a CDS view. And finally, we need to supply a subscriber, for example, Databricks, or it can be anything else. So the ODP framework utilizes a multi-subscriber model. So you can come with different subscribers and get the same data at different times. For example, if you want to pick up a Delta package, you can do that with different subscribers for different target systems. And if we do that, we again define the config, hand over the config, and load, and call the function ODP extract to extract this CDS view. We can do that as well, and we can take a look at that. And we will see that's in a data frame within Databricks. There we go. So we've got some additional columns here. One, we've got the timestamp when the data was loaded. We've got a batch number. We've got a row number within the batch. And we've also got the technical columns, change mode and entity counter. Those two columns combined tell us what kind of a merge we would have to do later on. Was it an insert, an update, or delete? And what type of an insert or update or delete was it? Was it a correctional booking, for example, and so forth? Now, because we did a full extract, these columns are null because there were no inserts, updates, but we just extracted the object or the HANA view in full. And then we've got the columns from the view, material group in this example here, material group name, and authorization group. And you can take a look at the data and scroll through. Right. The same, of course, is also possible for HANA calculation views. So these are HANA objects on the database. If you want to do some modeling on the database, you can do that, and you can extract the results from these views as well. You just need to know the name. It's a technical name then in the end. But if you do know the name, you can provide, again, the ODP mode and the ODP context, which is now HANA. Then you can extract that in the same way as the other CDS views. We can do that as well. And we can take a look at the data from this particular calculation view. So again, you've got these 5 technical columns. And then we've accessed some material numbers again. So material number, material type, and so forth. And of course, the mapping is done for you as well. Right, so now we've extracted everything in full, but it's also possible to do a so-called delta load or an incremental load. Not to be mistaken with the delta format, but we're now doing an incremental load using an extractor, which will be the material attribute extractor, which I'll show you. The mode, as said, it's going to be delta, and the ODP context is now SAP, which is an extractor from the ERP system. And we need to, again, define a subscriber name, and we can just use demo 909, for example, that ensures that none of these, that we're using a new subscriber to initiate that Delta load. And the rest is pretty much the same. So we can do that again, and we will get the initial load of that extractor, TOB attribute extractor. Again, we've got it in our data frame. We've got all different materials, material numbers, when it was established, when it was created, who created that, and all the properties of these different materials that we have in our demo system. All right, so if I would carry out this call again to the function, then we wouldn't get anything back, because in the back end, no new materials were inserted, or nothing has been updated or deleted. But if we do that, so if we head over to our SAP system, then we can, for example, create a new material. And we can just create any material, really, it doesn't matter. We can call it demo material. We need to define some industry sector. For example, chemical engineering. So some product. We can copy it from some other material, which I know exists in the system. And we need to define some very basic data. And we can simply save that material, our demo material. And so our demo material has been created. And we can go back to Databricks and see if we can load again using the same subscriber, and see if we can access that demo material and get it into Databricks. So as you can see here, so the change mode is now C1, which is an insert. Because we're now using Delta, everything is being described what it is. So the initial load, everything is our inserts. And if we load that again, using the same configuration, the same demo 909 subscriber, then we should be able to get that one row into Databricks as well. Surely here you are. So you've got C1, it was an insert, new material was created, and which is here our demo material. So we've got that in the system as well, and we could merge these two data frames now and have the same state of that ODP object within our Lakehouse architecture. Of course, you would set up, for the data scientists, you would set up the monitoring within Databricks. But for the SAP basis team, for example, they would perhaps like to do some monitoring within SAP. And because we are using the standard interfaces and the standard functions supplied by SAP, that is possible as well. So if we go to our SAP system now and call the transaction ODQ1 for ODQ monitoring, we will see now here that our material number Q is visible. If we click here, we can also see what technical name it is, so zero material attribute. And if we click that in, we will see now that the demo 999 subscriber was established here. And if we drill down, we can even see the number of requests. So there were two requests, one initial load and a delta load. And we can even drill further down here, and we can even see how many rows were accessed and when this was accessed. And we can even see the data that was transferred. So you've got full transparency also from within the SAP system, who extracted the data, what type of data was extracted, when it was extracted, and so forth. So far in the demonstration, we've loaded all these different objects into a data frame. And it's great if you want to test out things and you want to look at the data and explore the SAP system from within SAP, from within Databricks. But all these data frames, of course, you can also persist in your Lakehouse architecture, for example, in the Delta format. And to do that, you need to first mount your data lake, as you would usually do in Databricks. And once that data lake or data lake storage is mounted, you can call a different function, for example, table load, not table extract, and we can now write the table JCDS into our storage account over here. And once that's done, we are going to show the written files that we wrote in the Delta format. So if we carry out this command, let's see now the data is being extracted and the files in the Delta format have been written to our data lake storage. And once written, of course, we can read that back in, as you would usually do, any type of Delta formatted files, and we can take a look at the data frame here again as well. And we can again do a count, and we can see that we've loaded now 50,000 rows and written them to our data lake storage. So in summary, we have shown a really lean architecture, a solution which doesn't involve any ETL tools or VMs or anything else sitting in between. We've just developed a few functions sitting on your Databricks cluster, which enable you to securely connect to your SAP system and load any type of objects going through SAP standard interface. So you can securely connect, extract via the application layer. We do not extract from the database, so there are no additional licensing costs involved. The extraction is via the ODP framework, so it's a decoupling from the tables. And the monitoring is also possible from within SAP, so everything is transparent of what's going on and who's extracting the data. And by using this solution, of course, this will rapidly reduce the time to market for any data science and machine learning use cases that you might want to try out, because you can now explore the SAP data from within Databricks directly, and you do not need to set up anything else in between. So this concludes the presentation. Thank you very much, and see you soon.